Hi, hello. Can you hear me? Okay. Hi, I'm Andres Muñoz. I'm the project coordinator of Wilson Project. Okay. So now in this part of this workshop, well, first of all, thank you, Katerina and Peter, and all the people from TUE for organizing this meeting. Now we are going to show some of the technical advances we are doing in our project. But first, I'm going to give a brief introduction of what Wilson is doing and the purpose of this project. Okay. So Wilson is a Horizon Europe project. Okay, I think most of you, if not all, knows this framework from the European Commission. It's a 4-year project. We are in the middle of the project. We have only 2 years ahead. And the main focus of this project is taking what the previous presenters said, to take advantage of the data space architecture to develop or to provide new, more efficient and sustainable uses to the data in the build environment. Okay, for example, we want to use this data space solution to to provide this framework to the service providers to find new customers to their solutions, or for example, thinking about a data provider. Um, from my side, as a developer, I need data to test my solution. So how could I access data when I only have data, for example, from my building? If I want to test my solution in a different environment, like a hospital. Uh, so maybe the data provider, the data owner of this information, a hospital, could provide this information through the data space and also give value to the data. What are we building on top of this data space? We are working on different innovations. As you can see here, we are working on digital twins, not only focus on the buildings, but also in a district level, okay? Building a federated data mesh of digital twins. Also, to connect the solutions to the data space, we are working on some interfaces that we call personalized data hubs that provide, with ontology and data model, provide a common interoperability solution. Also, we have a P2P marketplace where the service providers and data providers could connect and interact and connect to different solutions. And on top of this work, also we have some specific solutions focused on different aspects of the building sector. For example, we have analytics and energy management solution, predictive maintenance, biodiversity and material passport for renovation in different phases of the construction, phases of a building, and also for diagnostics, risk and resilience, and SRI calculator. So all these innovations will be integrated in 8 different use cases that will be um, used in the 4 demo sites we have. Each use case focus on the different areas of the innovations that I explained before, for energy monitoring or predictive maintenance, biodiversity, and also we have included some investment planning use cases, thinking on high-level stakeholders. As demo site, we have 4 different demo sites on the project, each of them with 2 different use cases, and also we have a living lab where in our facilities in Zaragoza, in the facilities of the Circe Foundation, that is the coordinator. And we are focused on different aspects in each demo site. In UK, we have a district of the city controlled by the University of Newcastle, where we can test predictive maintenance solution and digital twins. In Spain, we have a hospital that we are focusing on improving the energy efficiency of this building that is critical for hospitals. Also in Italy, in Brescia, they are making renovations of an area of the city. We can test the biodiversity, the redesign solution that we are working on in these early phases of the construction project. And finally, in Switzerland, we have a rural area where we have a DSO in the project, and we can work on the distribution grid solutions, focusing on this area. Okay. So this is, in a nutshell, the idea of this project. Now, that we are in the ending the development phase. We are now working on making the first test in the facilities of each developer and also in the living lab. So now my colleagues, they are going to explain so far what we have and make some show about the innovation that we are working on. So I give the floor to Jan. He is working in the Swiss demo site, and he will show us a dashboard about how to interact with the data space. So please, Jan. So this one. Okay.
So, hi, my name is Jan. I work at SAK in Switzerland, and my goal, I was an intern, and my goal was to um, develop a connector, or specifically a UI that helps customers to maintain and work with a data space um, and share data over it. And as we work with customers that have like solar panels, batteries, and so on, our goal is to um, get data, energy data, and so on. So I tried this to make as easy as possible for people that are not familiar with technical stuff, but now I'm trying to log in. So it's really nice that it worked, because before I had a lot of technical issues just to um, access this page, because my login out of some reasons wasn't really working. So I just want to show what I'm trying to do. I've built, apart from I got the data space environment from the Hochschule Luzern, and they gave me what the data a catalog where you can negotiate directly and whatsoever, and create assets, policies, contract definition, and so on. But that's sort of really complicated if you are really new to um, data spaces and you are just owning a big solar panel and want to share data and so on. So I try to make an automation out of it, and designed two of these wizards where I can sort of make with subscription tiers and so on, and make it easy for a customer to um, share the data or give different allowances. For example, tier 4 allows everything over the whole span of time to access um, the, uh, the shared data. Yeah, I there would be the chance to configure also it manually, and make policies concerning the location um, to which um, source or SRK or somebody else it's allowed to yeah, who is allowed to access that data. To show, yeah, I could create an asset, but that doesn't help much. So maybe another thing I could show, which is now, this is the data space where I can transfer an actual asset that's already created some time before. I don't know if you can see down here. I created some assets yesterday from the Smart Me, which is located in Utzwil, which is the demo site. I can't show that now because I blocked myself to use my own assets. But what I can show is I can show that the data space works by selecting an asset that's made by the Hochschule Luzern. I can now run all the negotiations and all the transfers by just clicking a few buttons. This is just for debugging and other purposes. Now the whole process is running step by step. I could even show myself some details if it didn't work, but luckily it did work. And now I can show you that everything worked in the behind. And here I got some data which was provided from Hochschule Luzern just now, which they gave free over the data space from their connector. Yeah. I could have shown you data from solar panels, but there are somehow no solar panels connected. So yeah, that was about it. Yeah. Thank you. Yeah.
Okay. Ya, pero esto estaba antes. Pero ¿por qué? No, ese ahí. Lo han hecho así. Esta pasa. Cambiado. ¿Qué? Hi, I'm Aitor Alcrudo from Circe, and I'm going to present Circe Living Lab. So what's the Circe Living Lab for? This is what the paper, the GA says. The idea is that we have a place where we can control the data that we have, how the networking works, any issues, to be able to test all the solutions of the Wilson project in a controlled environment. So that, you know, we have issues with the pilots, we have issues with networking, we have issues with whatever. We can still test the functionality, we can still validate that all the use cases work. And how's the Circe Living Lab? Well, basically, we have our offices, we have an SCADA to control all the energy consumption, temperature, all the sensors, lighting. We have PV in the rooftops, we have batteries, we have EV chargers. So we can bring this for the project. We have also the BIM model for the building and allow all the solutions to be tested. Right now we are working on making it available and easy to use for everyone, and we already have some solutions deployed. So we have a key clock to be able to have a single sign-on for all the solutions, which is also compatible with the connectors from the data space that we are using. And then we can use it to for our tools. This is a tool that we have to standardize how the IoT data streams work. I'm setting here the connection to the third SCADA. The connection is internal to our network, but we can expose this externally. So it's like a gateway for our SCADA, and it allows us to map measurements and data and sensors from our offices in a standardized way. And also we can construct multiple mappings for the same data, because one of the limitations that we have right now for our data space is that you enable access at the endpoint level. But okay, so if my only endpoint is for all my data and I don't want that, so we can either create an endpoint for the database directly, or map an endpoint on the fly, so that you can get the granularity that you want and create, let's say, a virtual data source, a virtual asset with only what you actually want to give or create there. So right now I'm mapping all the data that I want to offer in this one. And then you save the mapping. And what does this mean? How is it used? Okay. So once you have the mappings created, you can view the mapping, and you have a preview of all the sensors, and we have also a Swagger, but it gives you a summary of how to use it, and then you can just authenticate into the key cloak, get a API token, and do the same queries for either a sensor, a list of sensors. You can ask, whatever data you need for whatever data time you need it for. This is one of the solutions. We have also the peer-to-peer platform. The idea is to have a more user-friendly way of managing, at least partially, the data space, and also we are planning on adding blockchain validation to the data space, although that's still a work in progress. Okay, it's working. So again, it's a bit the same. You have the key cloak, and you select your connector. This is one of the services that we have, is the local connector. So the local connector goes to a local data space when you can test all your solutions, and you add your connector to your user profile. And then you can test it, see what assets as a user you are offering, and you can subscribe to services. Yeah. So for example, you can see a service or subscribe to it, select the connector you are going to use. Yeah. And the same journey, but on the other side, it's when you have services to offer. So the idea is that we will add here all the services for the project, and you can select the connector that your service is going to use to pull data from the data space, and then create your service, give it a name, a description, a pricing. Of course, for the project, all the services will be free. but the idea is to showcase that you could try to see the limits and showcase how you could build a service platform that allows you to subscribe and work in an easy way with what we are building in Wilson. Of course, the Wilson Living Lab also has this is the GraphDB database of the BIM of the building, which is created by TUI. This is a description of, and this is all the classes that we have for the semantic database for the BIM representation of our building. We have also the local data space that I was talking about, and also the staging data space connector with the actual data space of the project. Other databases, we use Apache Airflow to be able to have batch processes that, if you need to process something regularly. An Nginx proxy setup, which works to reroute everything that's coming to our demo to the actual services, also handle the security in a unified way, an MQTT broker for IoT streams, and the PDH developed by TUI. The idea is that we are creating a sort of template that we can roll partially or totally on all the pilot sites with utilities and services for the tools in order to make the deployment easier for them. So, for example, the PDH is deployed, but it's also using the MongoDB, and it's also using the semantic database, and they don't have to, set up their own database each time. Some of it is already accessible, and this is, let's say, all the forward facing for the endpoints that we have, and this is internal services. For example, the Office SCADA is not exposed. It's just we have the canonical data service, and that creates the external facing endpoints. We have the local data space. We have the databases. We have another component that we used to be able to create endpoints from the databases that we had. And the idea is that we have all in Docker and in Docker Compose files, so everything is self-contained, but it's also sharing the same network, so it can talk with everything else. And with that, thank you very much. Thank you.
Hello, everyone. We have been talking about service catalog or data catalog and data spaces, but there is also a new component that we have been developing a part of Project Wilson, which has a lot of a couple of benefits that the original centralized or the conventional centralized systems or approaches cannot handle. And within the context of data spaces, it brings a lot of advantages in particularly in information exchange. So if we broadly see that this is just a three-layer architecture for any information system, where you have a data layer where all the data sources are on one side, and we have application layer where we have all the end user or business applications on the other end. And currently the information exchange layer is where the data space is largely about. And but there are a couple of complexities that when we are trying to deploy a data space for an information exchange. One of that is integration complexity. You need to have build connectors for all the data resources that we are using. And second thing, data space by design cannot store any information, but in practice we might need any aggregate a placeholder to store the aggregated information. And for those reasons we have included new component called PDH. This also works more like a data exchange layer, but it also does the aggregation services. So it includes a lot of aggregation services, and ideally the PDH connects directly to the original source, and it will not duplicate any data. And all the information, building information, are mostly stored in any third-party tools or legacy applications, which are kind of siloed one way. And to make them accessible, web accessible via data spaces, you need to convert them or using ETL procedures and other things. So that secondary layer of information has to be stored somewhere, and PDH is one such component that can actually handle these kind of second data usage layer. And PDH also give one point solution or faster way of communicating with data space, because when we start trying to use or create connectors for each data source, that becomes really cumbersome in terms of governance aspect. So that's where PDH helps. And other important application we also felt is that data space is not ideal in every case, where for data which is residing within the boundaries of the organization, you actually don't need data space to be used, and it is just data accessibility from any other middleware layer. So I'll be showing the demo of how we are using PDH in the Wilson context, both for direct accessing data for internal applications, and also accessing or sending information via data space to external applications. So here we have a couple of developed a lot of APIs related to RDF data. Even in the previous presentation, we have seen the building semantic data is stored in GraphDBs, and also the live sensor data that we are in the previous demo from the SmartMe application. So we are also getting the BMS information from the different data source of the building. And right now we are trying to use the current any sensor information that is directly accessible. So this you can directly use the PDH APIs for any internal business applications. However, we can also use this URL for doing or publishing that as a data asset in the data space. So what we are trying to say is sensor data publishing as a data asset, and there is a sequence of process, a sequence of steps that are followed from the provider context. They create assets, they create usage and access policies, they create contract definitions. And once that contract definitions are there, from the consumer catalog, we can also see this data asset as being part of federated catalog. Um, and we use those data assets that are already available using those offer IDs, and we try to negotiate the contract. And once this contract is negotiated, we can also see that this it follows some stages from started or initiated to finalized state. And once it is finalized, then we can use this contract agreement to get the actual data from the data space. And this is a kind of a consumer pull. So because in data space, most of the existing applications are consumer pull applications, meaning a consumer will request data. It is not the provider who will always send the data. And this is a classic case of consumer as requesting for the data. And but PDH also has, like I mentioned, a significant advantage of storing aggregated or secondary data. For in the even in Wilson, we have a lot of tools that are like holistically working for a particular single use case, and the tools output has to be stored inside the building information or PDH. And so for that we are using PDH, or we can also get any information from maybe energy rating, energy rates, or any other external trusted providers information, but that has to be stored within building environment for making decisions. So like I mentioned, the actual exchange happens in the data plane. So if we see data space, only connectors communicate, and the connectors are the two main components, provider connector and consumer connector, that exchange information. And a connector is modularized into two planes, control plane and data plane. A control plane is where actual the access policies or validation identity happens, and once this identity is approved, then the entire process will be moved to data planes. So in the first case, in the consumer pool, there will a consumer request for the data, and then I think, yeah, consumer request for data, and the provided data plane will actually ask for the data from the original source, and it will fetch the data and it will pass to consumer. But in provider push, so till the process of contract negotiation, it is same. However, only from the context of provider data plane, so it will fetch the data and it will just push the data directly to consumer. So this is a same example. I think we have for showing out. I've already created a location or a data endpoint where I can actually store the information from that is pushed by the provider. And for this reason, the other steps are same. So like creating asset, creating policy, creating contract definitions, they follow the same logic. Yeah, we get these offer IDs, and I can also quickly, once we have this contract agreement, we use this contract agreement to do the actual consumer push. So, and for publishing or pushing the data, you also need an API endpoint where that data can be stored from the in the consumer end. And we are using one of the existing collections that we have created for the provider or from the provider push. And we can see this information is again stored. Once this transaction is complete, and now I'm actually validating this information from the actual PDH. So we were trying to use the same collection where the data is pushed. Yeah, data is null, but it shows that. So this also shows that we can use PDH for bidirectional data from the data space context. We have been talking about only information exchange from one perspective, but this bidirectional exchange can help in particularly from the context of digital twin applications, where you also need some simulated information to be sent back to physical assets. In those cases, we can use PDH. That's all for. Thank you.
All right. Now we suddenly switch context, going from smart buildings to circularity in the built environment. But as I mentioned also earlier during the opening, as much as we maybe switch the context and also maybe slightly the application domain, quite of the challenges that we're facing kind of remain the same. And this is also our objective of today, to go a bit deeper into those in the 3 workshops after that. So then what we are facing with in terms of data spaces for construction is the notion of circularity, and particularly material reuse. It doesn't mean that, of course, data spaces or any sort of technology will enable material reuse or convince people to adopt circular solutions or circularity overall. But also following the presentations by both Frank and Marcus earlier, we can see that that can definitely be a support mechanism in tracking and tracing, and with that actually leading to a higher use. In that sense, Upscale is a Dutch-funded project by the Dutch Research Foundation, a 5-year project that started just about 2 years ago. So in that sense, we're still before halfway. And when setting up the consortium together with Peter in the beginning. He's the administrative coordinator of the project. I'm the scientific coordinator. One thing that we really wanted to have, and we really worked very hard for, are all of those people on the right. And of course, you always need partners. But one thing that was very important for us in this specific context is to actually have a representation from more or less the entire value chain when it comes to circularity in construction. So, of course, I think I don't really have to tell you anything about the statistics and why we do what we do with circularity or in general with any sort of technology in the built environment. We try to minimize some sort of negative impact, usually as an optimization problem. So that's of course our ultimate goal. But so what we are tackling directly in this project is this really lack of systematic solutions to be able to identify, track, trace, and reuse construction and demolition waste, be able to enable provenance, go back in generations of history of maybe materials or components that have been used across life cycles, but also make sure that this is possible forward in upcoming new life cycles of products, materials, components, and so on. And of course, this is not only a technical problem. So, of course, we see that there is a lot of lack of trust, general lack of maybe engagement in these processes. It's also a money issue because why would you buy a reused light switch for 4 times the price of a new component, right? That's a motivation problem there. But we also see that what we often do in the built environment is try to adopt already existing business models from other domains, such as manufacturing, and that doesn't really work for obvious reasons that I think all of us are familiar with. And of course, from a technical perspective, a technical standpoint, there is always this mismatch between provided and required information. It was also mentioned earlier that when we are talking about passports of materials, components, products in our domain, that doesn't mean that we have this one place, a bucket with all the information. It means that part of the information will be with the owner, the other part will be with the manufacturer. So really, this then points to the notion of decentralization. And ironically speaking, the construction industry is decentralized by definition, but most of the systems we use are centralized, and this is basically the motivation. And then our hypothesis in this regard was that if we use decentralized technologies, then we can maybe enable a little bit more that to use. So that also what that means in real terms is first and foremost, at a very basic level, be able to make sure that we have information that is linked to the actual materials and with that kind of establish a little bit more trust, engagement, and commitment by this being a very transparent process. Of course, we would like to be able to track and trace materials across life cycles, be able to see and enable the generation of product passports in a dynamic way. So not something that gets done once and becomes a file in a folder on somebody's desktop, but make sure that using a data space, we can actually enable the generation of digital product passports. And with all of that, also develop the specific circular business models that would enable this. So in that sense, Upscale is slightly different as a project. And that difference you will see in the middle, because the project does not only focus on technology only or the system perspective as you wish, or data spaces or decentralized technologies, but in a similar manner, we work with colleagues from behavioral and social science in the behavior pillar that you see on the right, and our third pillar is the economy, where colleagues from Delft work on specifically enabling corresponding circular business models. All that in 4 demonstrators that we have across the Netherlands, and those are interesting to highlight potentially as we have a building hub, literally translated. But what that is a material hub that Volker Wessels have across the country. Then our second demonstrator circle is a circular building, which was built in that way and also recently deconstructed with a new owner and that new owner has an intention to rebuild that building in a completely new location. This went wrong in all possible ways that I will not explain right now because things, of course, did not go as planned. The FOP is a renovation case of one of the largest banks in the Netherlands. And we have Huisrijk, which is a company that has the so-called open housing concept. So it's basically they're developing housing solutions in a source of an open source refinement way together with the community that give input on what those should be. Very soon, within actually a month or so from now, we will have 17 houses that will be deconstructed before the end of this year with the intention of them being reused. So this last part with Huisrijk, which is one of our partners, we will also get to make sure that we document everything as we need it, and we're able to actually enable testing of this track and trace aspects later on. And this is how these four look as well. Yeah, not much more to say anymore. On this project, you saw that we have 3 pillars within the project. Each of these pillars has one PhD student. And of course, our blessing, but also biggest challenge is to enable the integration between both. And us in TU Eindhoven, we are responsible for the system perspective, so the infrastructure. And I think in this specific case, I will already hand over to Krista, who is working on that. And what she will tell you a little bit more, and her demo in principle is this focus on digital product passports as a retrieval mechanism or a generational mechanism, if you wish, using the data space architecture that you also already saw several times today. So Krista, you are welcome to.
Thanks. Thanks for the introduction. Let's see. Okay, hi everyone. So I'm Krista, and I will give you a short demo to show how we use data spaces in the upskill project to enable circularity and material reuse. And I want to specifically focus on this building, which is the Foppinga Dreef in Amsterdam. And this building is actually renovated, and during that renovation, a lot of materials actually become available, such as doors, but also floor tiles, walls, lamps, and suspended ceiling elements. And some of them are actually reused in the same building, but there are also elements that are reused elsewhere, such as this suspended ceiling element. So 1/3 of these elements are actually reused in the same building, and 2/3 are actually reused in other office buildings in the Netherlands. And to enable this, we actually need a digital product passport. And in our project, we actually assume that this product passport is a modular product passport where the information comes from different actors. So for example, you have the manufacturer, the architect, and the element owner, each creating specific information about this element. And in the end, the deconstruction company of the renovation project actually needs this information to enable the reuse. So therefore, we need a data space where the data providers transfer the information to the data consumer, which is in this case the deconstruction company. And then you get this image that Ekaterina already showed. And today in the demo, I actually want to show you one data offer and one data retrieval. So that's only one part. So for example, the architect that offers the DPP, ODP. Actually, my data that I'm showing is a DPP composition part of the passport. Then they offer that with a usage policy. It becomes available via their connector. Then we need an agreement, and then the deconstructor can retrieve the data. And to do this, we actually need to follow this 6-step workflow. So first, I will just show that actually. So here we actually see the data provider's view. I will start the video. And here you see that they first need to create the asset. So they need to indicate the asset ID, but also the location where the asset is located now. So now this is actually a public link, which doesn't really make sense to share that via the data space, but it's only for the example. And as you can see we are sharing this turtle file. So then after that, oh yeah, sorry, I'm also showing the data actually. So this is the data that we're sharing. Yeah, and after that, yeah, you of course run it, then you see that it works. And then we're creating the policy. So here it's actually a bit stupid because in this example, there's actually no content of the policy, but the purpose of this policy is that the data provider can actually say what the data consumer is allowed to do with the data or not. And in the end of my presentation, I'm going to say that it is really important. So it's a bit stupid that I show an empty policy here. But when you run it, you actually see that the policy is created and that there's this policy ID. So now we have an asset and a policy, and then of course we need to link it to each other. So that's what we do here, and then we actually create the initial contract from the data provider's perspective. So here you can see that we link the asset to it. And the nice thing about this is that we can actually reuse the policies that we created and link them to different assets at the same time. So then here we can actually also see that it works. And then we go to the data consumer's perspective, which you can see in this video. So now the data consumer actually wants to retrieve this asset, but first they actually need to find it. And they do that by fetching the catalog. So here they can see which assets are available, and then they also see that it has a policy. So we actually copy this policy ID, and then we can start the contract negotiation. And now, as we literally copied the policy ID, it actually means that we use the same policy. So now this process is actually automated. So as we use the same policy as the data provider requested, it will automatically be accepted, which is what we will see in the next API. Yeah. So here we copy the negotiation ID, and then we see that it's finalized already. And then we receive a contract ID, or sorry, an agreement ID, and then we can use that to actually retrieve the data. So we copy the contract ID, but here we also need to say where we actually want to receive the data. And that's also what Avinash already showed. So now, like, I send it to my local host, but you can send it also to another system or application. But yeah, for this purpose, it's just the local host. I think I'm even showing, yeah, so here I make the local host. And that's actually where we will retrieve the data when it works. So we run this, and then we get another ID, the transfer ID, and then we can also use that to check the status if you like. But now you will see that it's actually completed, and when we go to the local host, you will also see that we received the data. So yeah, that's actually what you need to do for one piece of the digital product passport. And as you can imagine, that gets complicated really easily, because if we assume that the passport is modular, you need to do this for only one suspended ceiling element, maybe even 5 times. But imagine if you have an entire building with a lot of digital product passports, then this gets really messy. So that's why we also explored user interface design a bit, and this is really like the thing that we made was really actually just for fun. So I'm only showing it here for the purpose of saying to you that we actually need an interface that is user friendly and also supports the workflow, and that is also understandable for non-technical stakeholders, which we have a lot in our industry, because if we can't like make the data space less technical for non-technical people, then it will be very unlikely that they will actually adopt it in the in the construction industry. So yeah, that's something that we actually need to think about. And then I want to finalize with discussing a bit the challenges that we face in our project. So first, the actual organization of the data space. So now we actually don't have a conclusion yet on if we actually need one big data space for the entire construction industry, or if we need a data space per building, a data space per element, and also if we have multiple data spaces, how we avoid becoming into islands of data spaces. So how can we also link the information of one data space to another? Then also creating this efficient and effective workflow that actually supports the reuse of the components and materials. Then the defining and enforcing of the usage policies. So now it's actually really unclear what the minimal requirements of these usage policies are to to support the data provider to actually share their data, but also to leave enough freedom for the data consumer that they actually can use the data that they need. And then, of course, also the creation of verified decentralized digital identities. So how do we actually do this? And also, can we reuse these identities across data spaces if we have multiple? So that was actually what I wanted to share. So hopefully you have a small insight now on how we use data spaces in the Upskill project. And if you're interested, you can also follow our project on LinkedIn. Okay, thank you.
All right. Now I don't know. Any questions to Krista? Also, any questions to any previous speakers? Come up with any. If not, yeah.
Basically breaks down to formulate or breaking down contracts between companies down to very small operational factors. So comparing basically durations like who should or who should be responsible for breaking down the paper-based contract to make data loyal down to
Yeah, well, the only thing that I can say is that we recognize this problem as well. And we had several discussions about it, but we don't really have a solution to it yet. But yeah.
Mohammed, that's a good one for later on today, because I think a lot of the things we discussed here. So even if we're not sure, we have the trifecta of data, qualities, and identity. And now, what is the elastic or dynamic movement between these three motions in that trifecta? But you have a very good point, is that we almost assume all of these digitally present online, either as a or as practices. Fact of the matter